Assalamualaikum. I am Juhaima M. Makalngan, and our report is the chapter 11, entitled The 19th Century Contributions from Lobachevsky to Hilbert. So my topic is from 11.1, the attempts to prove the parallel postulate by the efforts of Proclus, Playfair, and Wallis. So let's get started. According kay Euclid about parallel, if a straight line falling on two straight lines makes the interior angles on the same side less than two right angles, the two straight lines, if produced indefinitely, meet on that side on which are the angles less than two right angles. The ancient Greeks were aware that certain curves may approach nearer and yet not meet, as the hyperbola approaches but does not meet its asymptotes. Even si Euclid mismo ay parang hindi pa rin siya naniniwala sa postulate, kaya na-postpone yon using his proofs until umabot siya sa proposition 29 of book 1. Maraming mga nag-substitute kay Euclid to prove the parallel postulate, pero lumabas na it was all logically equivalent to Euclid's actions. The most frequent substitute is known as Playfair's axiom, although it was stated as early as the 5th century by Proclus. So si John Playfair's element of geometry ay isa lang siyang detailed presentation ng mga naunang books ni Euclid, along with a supplement embracing the appropriate calculation of pi and some solid geometry. Binalak rin ni Playfair na palitan ito with the statement na through the given point daw on a given line, not on a given line, only one parallel can be drawn into a given line. So, mathematicians from the Greek onward have compiled a long list of statements equivalent to the parallel postulate. So first, a line that intersects one of two parallel lines intersects the other also. And second, there exist lines that are everywhere equidistant from one another. Pangatlo, yung sum ng angles daw of a triangle ay equal sa dalawang right angles. And fourth, for any triangle, merong nag-i-exist na similar non-congruent triangle. Panglima, any two parallel lines have a common perpendicular. And sixth, may nag-exist daw na circle na nagpapass through any three non-collinear points. And seventh, basta daw parallel ang dalawang lines to the same line, then parallel sila onto each other. So, ang pinakaunang effort na nag-prove sa parallel postulate was made by Proclus from his commentary on the first book of Euclid's Elements. Then, Proclus derived that we call Playfair's axiom, hence by implication the parallel postulate. All the numerous and varied attempts to prove postulate on parallels failed, although for a time some mathematicians thought that they have succeeded. Nag-fail yung iba kasi yung reasoning daw nila was otherwise fallacious. Mali yung naging paniniwala nila about postulate. So, isa na dun sa mga proof na yun is yung ni-present ni John Wallis. While lecturing at Oxford University, nagtangka rin si Wallis na palitan yung parallel postulate by a new axiom kasi feeling niya plausible naman yung idea niya and that should be therefore be given precedence. And so, he suggested that to each triangle, may nag-i-exist daw na similar triangle of a arbitrary magnitude. So, dahil sa assumption na yun ni Wallis, nagawa niyang mapatigil yung Playfair's axiom, na-hold yung Playfair's axiom. Hence, so does its equivalent pa rin sa the parallel postulate. Next is Saccheri quadrilaterals. So, si Saccheri, Lambert, and Legendre made important contributions to what we call now non-Euclidean geometry. The fundamental figure of Saccheri's investigation was quadrilaterals ABCD, in which the sides AD and BC were equal and perpendicular to the base AB. These quadrilaterals have subsequently become known as Sakiri's quadrilaterals. And there are these three possible Sakiri's quadrilaterals. I'm sorry, this is supposed to be an angle sign, but hindi ko mahanap yung symbol. So, number 1, angle C is equal to angle D, greater than 90 degrees for the hypothesis of the obtuse angle. Second, angle C is equal to angle D, less than 90 degrees for the hypothesis of the acute angle. And pangatlo, yung angle C daw is equal to angle D, which is also equal to 90 degrees for the hypothesis of a right angle. For any triangle with angles A, B, and C, Lambert demonstrated that the area A is equal to K squared, bracket 180 degrees minus another bracket A plus B plus C, where K is a constant of proportionality. Although the range of Lambert's research interests was enormous, he is remembered today mainly for having given the first rigorous proof in 1760 proof that the number pi is rational. Rigorous yung proof niya, which is yung number pi daw is rational, in a paper presented to the Berlin Academy in 1768. Ipinakita niya na if x is a non-zero rational number, alinman sa ex nor tan x ay hindi magiging rational. So he proved that because tan pi over 4 is equal to 1, which is a rational number, it can be inferred that pi over 4, hence pi is irrational. Lambert also suggested that e and pi are transcendental numbers, but proof of this would have to wait 100 years. And next, the accomplishments of Legendre. The most tireless pursuer of a proof of the parallel postulate was the third member of the great trio, which is itong great trio is sila Lagrange, Laplace, and Legendre. So si Adrien Marie Legendre came from a well-to-do family in the south of France, but spent the greater part of his life in Paris. So dito, the work of Legendre, he did not approach the achievements of Lagrange and Laplace. Kaya na-held siya for a while. Kasi yung work ni Legendre, parang hindi siya umabot yung achievement niya, hindi umabot sa yung nagawa na ni Lagrange and Laplace. So in 1878, Legendre read a memoir to the Academy with the title Richesses d'analyse indeterminate. So this contained the celebrated quadratic reciprocity law, which is concerned with the solvability of the pair of quadratic consequences. Ito siya. Legendre took for granted that there were an infinite number of primes in certain arithmetic progressions. And Legendre adopted the proof of the quadratic reciprocity law given by the young Gauss. Legendre's essay was later expanded into his Theorie des Nombres, the 2-volume third edition, together with the Gauss's distinctions arithmeticae, became the dominant work on the subject for the remainder of the century. The accomplishments of Legendre. So both Legendre and Gauss, so dalawa sila, the latter still in his early teens, hoped to end a simple function whose values approximated of those of pi of x, the function which gives the number of primes less than or equal to x. Legendre and his essay sur la théorie des nombres stated that the function, so ito yung accomplishment ni Legendre. Naka-stated sa kanyang essay sur la théorie des nombres that kung kung itong function na to, x over log x minus 1.08366, ito siya, and agrees very well with the pi of x as long as yung x daw is not greater than 1 million. Although Gauss na-discover din ni Gauss that itong integral na to ay nag-produce ng mas better approximation that Legendre's guess. So, pero he never published the result of his investigation. The first major progress concerning pi of x is attributed to the Russian mathematician P.L. Chebyshev, 1821 to 1894, around 1850. So, around 1850, ipinakita niya itong inequalities, itong equation dito. So, valid daw yan for all x sufficiently large kung ang limit natin ay ito. So, kung ang limit na to ay nag-i-exist, then the value must be 1. However, the existence of the limit turned out to be very difficult to prove. It was finally established in 1896, 100 years after Legendre's and Gauss's conjectures, by means of new and powerful methods, primarily from analysis. Then, Legendre's elements de geometry. The clarity of Legendre's exposition and the attractiveness of his style made the Elements de Geometry one of the most successful textbooks ever written. So, sumikat itong gawa ni Legendre. 20 editions of this book, comprising some 100,000 copies, appeared in France alone before the author's death in 1833. The first translation, yung unang translation, English translation ng itong Legendre's Elements de Geometry was made in 1819 by John Farrar. The next translation ay dumating noong 1822 by the famous Scottish essayist and historian Thomas Carlyle. So, nagkaroon rin ng rival si Legendre, which is si William Chauvenet. Kasi he prepared his Treatise on Elementary Geometry in 1870, which was there any successful American na naging rival ni Legendre. So, Legendre, much like Sacchery and Lambert before him, approaches the thorny question of the parallel axiom from the side of the angle sum of the triangle. He correctly perceived that Euclid's fifth postulate was equivalent to the theorem that the angle of sum of a triangle was equal to two right angles. So, after nun, nagkaroon ng argument about dun sa kung paano ba i-prove ni Legendre yung elements de geometry niya. So, in the argument, nabanggit doon that if the sum of the angles in a triangle is equal to two right angles, the Euclid's parallel postulate holds. So, kung na-prove nila na yung sum of angles in a triangle daw is equal to two right angles, so ito yung giprobahan nila. Ibig sabihin, mahuhold yung parallel postulate ni Euclid. Matitigil siya. Then, next na nasa argument, let angle A be any angle of the triangle ABC, then there exists a triangle A1, B1, C1 with the angle sum as triangle ABC and such that angle A1 is less than or equal to 1/2 angle A. And last, the angle sum of a triangle is always less than or equal to 180 degrees daw. So, my next topic is 11.2, the founders of non-Euclidean geometry. So, sino nga ba itong mga founder ng non-Euclidean geometry? Gauss's attempt at new geometry. When mathematicians were bound to realize that the unending record of failure in the research for a proof of the troublesome postulate was no due to any lack of ingenuity on their part, but rather to the actual independence of the fifth postulate from the other axioms. In the first third of the 19th century, that Gauss in Germany, Bolyai in Hungary, the Lobachevsky in Russia were discriminating enough to reject a postulate that for 200 years have been the main cornerstone of geometry. The notion of replacing the parallel postulate with a counterintuitive axiom that through a point not on a line, there exists more than one parallel to the line. So Gauss was the first to reach any advanced conclusions concerning a constant geometry different from that Euclid because he failed to make public his thoughts on the subject. The honor for discovering non-Euclidean geometry is usually divided between Jan Bolyai and Nikolai Lobachevsky. So si Gauss yung unang naka-reach ng advanced conclusions about the non-Euclidean geometry. Pero dahil hindi niya pinalabas, hindi niya gi-public yung idea niya, so yung honor for discovering non-Euclidean geometry is napunta kay Jan Bolyai and Nikolai Lobachevsky. Gauss, who was recognized in his own lifetime as one of the greatest mathematicians, would choose to withhold publication of his non-Euclidean geometry, lest its unpopularity damage his reputation. But in the early 1880s, the immense authority of the German philosopher Immanuel Kant, 1724 to 1804, still dominated the intellectual world. It was only in 1770, at the age of 46, that Kant was appointed professor of logic and metaphysics of Königsberg, the post he held until his death in 1804. The 12 years from 1769 to 1781 were spent in the most profound speculation of the philosophical issues he ultimately presented in the Critique of Pure Reason. The theorem concerning the sum of the angles of a triangle seemed to provide an experimental means for deciding once and for all which geometry, his or Euclid's best described the space of our physical experience. In the traditional geometry, the Euclidean, the angle sum of a triangle is always 180 degrees, but Gauss's new geometry predicted a result less than 180 degrees. So sa idea ni Gauss is yung triangle daw is predicted a result less than 180 degrees. So Lobachevsky conducted a similar experiment with angle sums, the result of which were published in 1829 in his treatise on the foundations of geometry. The only difference was that he analyzed some existing astronomical measurements to test which geometry best accounted for the data. Lobachevsky calculated that the angle of sum and triangle determined by the Earth, the Sun, and the axed star Sirius differed from 180 degrees by an amount less than 0.00004. Then may ganun na sign. I don't know how to read that. And last sa topic ko is yung the struggle of Jan Bolyai while proving his theory. Gauss did not go further in recording his earlier investigations. Was that on February 14, 1832, he received a copy of the famous appendix of Jan Bolyai. So Jan's fathers, which is Wolfgang Bolyai, had studied in Jena, then afterward at Göttingen from 1796 to 1799. Gauss and Wolfgang discussed problem related to the theory of parallels. Itong si Gauss and Wolfgang is mag-best friend sila. Then on 1804, Bolyai, convinced that he had succeeded in proving the parallel postulate, sent a little tract on his subject, Theoria Parallellarum, to Gauss. The reasoning was incorrect that through any three non-collinear points, there passes a circle. Bolyai mailed a supplementary paper to Gauss 4 years later. So, si Bolyai nag-mail siya ng supplementary paper kay Gauss 4 years later, but when there was no answer, na-discourage siya in his theory of Göttingen parallels and turned to other matters. So, after this, nung wala nang na-receive si Bolyai na reply galing kay Gauss, he turned to other matters. So, ang ginawa niya dito this time is nag-military na lang siya. Then, later on, his ideas on elementary mathematics were collected in a large 2-volume Tentamen Juvenutem Studiosum in Elementa Mathesius Porre, which is an attempt to introduce studious youth to the element of pure mathematics, published in 1832 to 1833. Although it bears the date 1829, it contained an appendix composed by his son, John. So, ayun, nakakompose din si John, which is yung appendix. Then, the chief claim to fame of Wolfgang Bolyai must doubtless be that he was the father of John Bolyai. The father gave the young boy early instruction in mathematics, and his progress was so quick. And when Wolfgang was sick on the occasion, he did not hesitate to send his 13-year-old son to teach the college classes in his stead. So, fast learner tong si John Bolyai. So, dahil madali siyang natuto, hindi nagdalawang isip si Wolfgang na nung nagkasakit siya is instead na siya yung magturo, is yung anak niyang 13-years-old son ang pinagturo niya sa isang college. The elder Bolyai hoped that John would go to Göttingen and study with his old friend Gauss. John Bolyai had from his father some of the inspiration to original research that the latter had received from Gauss. While in the academy, John was giving his attention to parallel postulate, though first on the side of proving it. Recalling his own unsuccessful efforts, Wolfgang urged the boy not to become preoccupied with the theory of parallels. After several vain attempts to prove the parallel postulate, so finally, the young man began to think of it as an independent assertion and succeeded in constructing an entirely new geometry based on the denial of this axiom. He did not know that the same idea had already occurred to Gauss and Lobachevsky. Wolfgang Bolyai's vivid presentiment was fulfilled by the coincident discovery of non-Euclidean geometry by his son, and Gauss and Lobachevsky. John Bolyai's treatise was printed separately under the title Appendix Scientiam Absolute Verum Hexivens, in English, Appendix Explaining the Absolutely True Science of Space, and appeared before the volume of the Tentamen, which was afterward bound up. Excluding the title page and one that gave an index of notation, the work itself contained only 24 pages, which have been described by George B. Hasselt. So, as the most extraordinary 24 pages in the whole history of thought. Bolyai's mental depression deepened when the appendix met with complete indifference from other mathematicians. So, na-depress dito si Bolyai kasi nung first, akala niya is yung gawa niya is parang hindi nabigay sa kanya yung credits, hindi nabigay kay John Bolyai yung credits, parang doon siya na-discourage kasi before niya yon na i-publish is may nauna ng naipalabas yung father niya, which is yung appendix na gisent ni Wolfgang kay Gauss. So that's why nadagdagan yung mental depression niya when the appendix met with complete indifference from other mathematicians. And for so long periods, he did not almost nor creative works. The final disappointment came in 1848 when Lobachevsky's Geometrische Untersuchungen zur Theorie del Parallelism reached him through his father. So dito talaga yung mga time na nag-struggle si John Bolyai. Kasi parang yung pinaghirapan niya is hindi nagmula sa kanya yung credits. So hanggang dun lang yung report ko, and for the other content of chapter 11 will be discussed with my group members. That's all. Thank you.